Hi, everyone. It's good to see you. My name is Ted Zeroni. Chris Zarsky is not able to be with us today. She's off traveling around the countryside as usual, very busy. So I'm here today by myself offering this session on exploring the new science curriculum for grade 2, and this is energy. I should add, by the way, that despite Chris not being here, there is another video that will be added on to this one a little bit later on at the end of this session. So you'll get both this front end part and the resource sharing part that Chris typically does at the end here. So welcome, everyone. This is the last session for grade 2. The next session we're doing is space, and as we know, space begins only at grade 4. As we usually do with the beginnings of our meeting, I'd like to begin with our acknowledgement of land and people. But before I read it, I would like you to just listen to hear what Stephen Paquette has to say. He gives us some things that we should be considering and acknowledging as we hear not only this acknowledgement of the land, but when we are present when other acknowledgements similar to this are read in different places that we may be.
What I've learned from my elders is that when we do acknowledgement of the land, it's not about acknowledging whose land it belongs to, because that indigenous worldview, we never owned the land. We were simply caretakers of it for future generations. And what I've been taught from my elders is that when we do that acknowledgement of the land, it's much more than just the territory. It's about relationships. It's about our relationships with people that share the land. It's our relationships with Mother Earth. It's our relationships with the four-legged, the finned, the feathered, the crawlers, the original stewards of Mother Earth. It's that relationship that we acknowledge with the trees. It's that acknowledgement that we have with the plant life that is part of the food chain and helps us exist. It gives us our medicines for healing, gives us food for nutrients, it gives us our medicines for ceremonies. We acknowledge water. Water is sacred, water is life. And what we're told is that when we acknowledge that water, that we always have to acknowledge the carriers of those teachings, which are the women. So we do that in the same voice. We also acknowledge the infinite wisdom of the grandfathers. Then we take that to the next level, is which acknowledging that relationship that we have with father-son, or in some nations, brother-son. We acknowledge that relationship that we have with Nokomis, Grandma Moon, and how she cleanses Mother Earth. We acknowledge that relationship that we have with our distant relations, the star people. So when we talk about acknowledging the land, it's so much more so than just acknowledging what nation was on that. As we know all throughout the history of Turtle Island, is that indigenous people were, for the most part, nomadic people. They shifted. They would move from season to season. It just so happens that Sheridan sits on the treaty territory of the Mississaugas of the Credit, which I'm very proud to always share and educate with people. But in the same breath, I also acknowledge that many, many other nations have walked this territory, and that their ancestors are still here amongst us.
And then keeping in mind, as we listen to the acknowledgement of land and peoples, that we are fortunate to live on a land that's full of wonderful people, things, and nature that we can build relationships with. So keeping in mind all the relationships we have with the land and the people who are with us on this land, in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. Now, I should also mention that this is a re-recording of the original session from this afternoon. Without Chris being here, getting that rolling, I got too excited to get going and forgot to press the record button. So this is a different recording than what was offered to those who were with me live earlier this afternoon. Anyway, at the end of the day, we hope that as you view this, that you do continue to gain increasing confidence with navigating the new science curriculum, that as we've been through the sessions, that you've gained a sense of direction, you know where you have to go, and that now that you know you have to go, you do where you have to go, you have the efficacy and that sense of confidence to move forward with it in the direction that you want it to go, and you have the skill set and supports in place to make that happen. The agenda is very similar to what it has been for all the other sessions. We know at times some people are here for one session or for most sessions or all sessions. So we try to keep the front end a little bit similar so that if someone is seeing this for the first time, you won't miss out on this sort of foundational piece. Now, and once again, so we'll take a look at the cusps, the knowledge, concepts, the understandings and skills procedures. We'll touch briefly on instructional considerations and assessment considerations. And Chris's video will provide lots and lots of examples and resources that you can access to get yourself going with this, this organizing idea energy. Once again, the structure of this curriculum is the same as all the other curricula that are being implemented. We've got the organizing idea, that's the broad scope of the organizing idea. And it's narrowed down through the guiding question and learning outcome. In this particular case, students are investigating the sources, pathways, and behaviors of light and sound. And then, as we know, we have the 3 columns of information below that. That's the knowledge, understanding, skills, and processes. And that's where we'll be focusing much of our time for this front end part, is on those 3 components. This science course is a little bit different than maybe ones perhaps that we currently have and ones that have been in the past. And one of the key differences is the continuation of concepts and understandings as the grades progress. So if we take a look at, for example, energy, which is the organizing idea we're on now, we see that in kindergartens, children explore movement, and that movement is focused on humans and animals and objects, but mainly human and animals, how they move, the ways they move, and so on. And that idea of movement still continues into grade 1, and we take a little bit more specificity at the pathways of objects that move and the speed of moving objects as well, their direction. In this organizing idea at grade 2, we're looking at movement and pathways as well, but more specifically with light and sound. And finally, by the time we get to grade 3, the idea of forces and how forces affect movement is taken a look at. And of course, grade 4, 5, and 6 continue to work on energy. Grade 4 moves on with forces and how they affect movement again. And by the time we get to 5 and 6, we only look at energy as forces. With that, we also introduce the idea of energy as a natural resource when we get into grades 5 and 6. There's 2 outcomes associated with energy in 5 and 6, excuse me. I often begin with a little look at where we're at. I won't play the video. You should have the link to it when you do get your download your PDF if you want to look at this. But we know we're living in a world very different than one that we went to school with. There are lots of things that are challenging on many fronts, as you can see from the list of things I have there. But with these challenges, I'm a firm believer have opportunities for improvement and moving forward. I guess I actually pressed this. You can see what I had here with this little robot, amazing little thing, how it can move on its own with motions of a real person. Quite incredible. It waves, it balances by itself, and does the old as it tries to regain balance. And that's an old video, and so we know that things are changing rapidly. Things are more sophisticated than this video you can even demonstrate, given it is a few years old. So we do have a very unique and challenging position to be in as educators. And we think that the key to helping students be most successful in this new and changing world that's full of opportunities, but full of challenges as well, is to consider that at the end of the day, what we want is our students to leave our classrooms and our schools with the skills and attitudes and values and knowledge that they need to be successful in this new and unpredictable world that we're moving forward in. And the question then becomes, if transfer is our collective goal, what is it that we need that's going to be helpful for them to transfer, and how do we do that if we can identify those things? We do know that what does transfer our skills, and I suppose if we asked any of us, any of us, what do kids really need that will help them out most when they leave us at the end of the day? Skills are some of those most important things. We want kids and as adults to be critical thinkers, want them to be able to evaluate what they see and read and analyze. Those are the hard thinking skills, but we also know that there's some social, emotional, and softer skills for themselves, be empathy, to look after oneself, to be regulated emotionally and learning those skills of how to do that, to work with others through collaboration, conflict resolution. Those are all things that we know students need to be successful as they grow up. And the question becomes then, when do they learn those things? How do we teach those things? And that's some of the things we hopefully can look at with the science curriculum, is how we can take some of these skills, isolate them, and get kids to be competent in them within them, so they can transfer them to the different aspects, not only in their educational careers, but their personal lives. So not only do skills transfer, but concepts transfer. Just as an example, if we take a look at the concept of courage, we have two separate contexts here, but in each context, you could probably identify courage. In this case, we got a plant growing in a field of sand or in a large area of sand. How might that show courage? What do we know about courage? And the other, we have a picture, an image of a person standing up on a very tall ladder. How does that show courage? Is independence, there's another concept, is that visible in both? And we could probably argue, but both of them are examples of courage. They could both be examples of independence. And that's the nature of concepts. They can transfer from context to context, place to place. Understandings are made up of concepts, which we'll soon see, and they are also transferable. So understandings are just larger statements that include many concepts. I have two here. Unfortunately, they're from the grade 1, but I could have brought in any grade 2 examples in here as well. But here's two understandings. One is movement occurs in different directions. And if we were standing there watching this person sanding this piece of looks like a piece of wood, we would know that, yeah, a sander and the person is moving in all kinds of directions, and we'd be able to show that and demonstrate that. It also has the understanding that some properties of objects can be physically changed. And we could demonstrate that, saying this is, in this context, that is also true, because we could see this piece of wood going from maybe what be smooth to even smoother yet through the sanding process. And that would be the physical change that has occurred there. So at the end of the day, then, the knowledge, especially the concepts, they transfer. The understandings transfer outside of the school, and so do the skills and processes. These are things that kids transfer and take with them as they move forward. Once again, the knowledge is those facts, symbols, rules, and principles and concepts. Most of the knowledge in the science curriculum here is made up mainly of concepts. There are some facts, a few rules and principles, and not much for symbols, but there are some as well. But it's the concepts and principles and rules that do transfer. Understanding is how the knowledge, so you take the stuff of knowledge and the concepts out of the knowledge content, and they're put together in a logical and meaningful order in the understanding statement. And as I just examined through the other pictures of the sander, those understandings transfer as well. And finally, we know that skills transfer, and the skills are what students do to demonstrate their knowledge, and they're what they do to demonstrate their understanding. And when they can do that, that's a move towards transferring those things. So to begin with, then, let's start with a concept. A concept is simply an organizing idea of one or two words. In this case, a chair is the concept identified here. Concepts have distinct attributes, and we would say the distinct attributes of chairs could be 4 legs, a piece of furniture made for seating. But when we look at these other examples, we know that a chair is more than that. It's not just a piece of furniture with 4 legs made for seating, because if that's what it was, then the images that just showed up below would be chairs, but they're not. They are a different concept. Those are stools. And so we carefully define each of them, and the distinguishing feature that separates a stool from a chair perhaps is that a chair has a back, whereas a stool does not. Anyway, so concepts are all around us. And there, as you probably know, concepts can be arranged from very general to quite specific. The more general the concept, the more likelihood it is able to be transferred from one context to another, from one time to another. from one course to another, from one discipline to another. So energy is one of those fairly broad concepts. We know that we can see, we can look at energy in science. We can look at it in phys ed and wellness. We can take a look at it in dance. We can see how we can examine subjects in those with that concept of energy. We know that as we dig down deeper, we get more specific with the concepts, and they become a little bit less transferable. They become a little more anchored within the discipline. So the deeper you go, though, the more knowledge, the more understanding, and the more stronger structural understanding you have of that discipline. So both are needed, and definitely the deep ones also help to create a broader understanding of the subject itself. And we did mention that, yes, concepts are transferable. And because they're transferable, it allows us to focus in on different things by using it as a lens. If we say, I'm just going to go backwards to this other photo, for example. If I was just show you this picture, the one on the left with the youngster standing there, and I asked if you can see courage there, you might say yes. But if I asked to use the lens of natural resources, you would suddenly focus on that. You may not notice that there were little trees on the side and some in the background there. You might have noticed the mountains and so on. So we could talk about landforms in this, we could use that as a lens as well and see different things. So because concepts are useful for lenses, let's take a look at this organizing idea through that lens, the lens of concepts. The concepts in our science course is all over the place. It's in the organizing idea, it's in the guiding questions, the outcomes, and all the cusps. And when you look carefully, you'll see some of those concepts repeating themselves, and those become the major concepts. What I'd like to do is just highlight those concepts. So we've got things like characteristics. What makes a characteristic a characteristic? We've got vibrations that has certain qualities that make vibrations a vibration. Some things are sound, some things are taste. What makes sound a sound? We have materials. What are materials and what would be classified? What examples of materials do we have? What is texture? What are some examples of the different textures we can have? So these are all examples of concepts found in the curriculum, and you can see that it's lit up with many of them. You'll notice that some of them are in brackets, things like investigation. Those are concepts related to the verbs. So the verbs themselves, such as investigate, students investigate something, that's an action, that's not a concept, but those action verbs do have concepts attached to them. So if you're investigating something, you're conducting an investigation. And an investigation is a particular product that has a process that has certain steps to follow. And so it is a thing. We can conduct an investigation. It's a concept. If this is just one line of the entire organizing idea, and you can see how many of these words are actually highlighted. And what we want to make sure to do then is make sure we spend our time on those concepts that seem to be the anchoring ones. They're the ones that really set the pathway, I guess we could say, for the organizing idea. In this particular organizing idea, light, vibration source, characteristics, pathway, and objects are the key concepts. The learning outcome uses the word behavior in the outcome, and it's perhaps another way of saying that light and sound have that movement of that, and that's related to energy, because light and sound do behave or do move in particular ways. As I mentioned, when I define the concepts, they do have definitions, and we find those in the knowledge column. In this particular case, there's a definition for vibration, which is a rapid back and forth movement. And sometimes the definitions aren't there. So we have the word concept prism, for example. It's not defined there. We'd have to look somewhere else. I should have highlighted the word object because that is another concept that shows up right from kindergarten. And we have to go back to the kindergarten science curriculum under the organizing idea of matter to actually find the definition of object there. So if you have the PDF of the curricula, sometimes you want just to find if you don't find a definition for it, you can Google the K-6 curriculum as one document, and you'll find the instances of it showing up. And sometimes you could find the definitions there. And once again, one of the criteria of a concept is that it has examples. In this particular case, knowledge column does have examples of many of the concepts that are used in this curriculum. Sources is a concept, and they give examples of the sources, examples of sound sources, and they do give examples of light sources as well. So you'll see a list of examples here, and that often shows up in this knowledge column. So knowledge column, for the most part, has lots of concepts, their examples, and every once in a while, there will be some facts thrown in as well, which aren't transferable, but they're things for kids to know and recall. I'm not going to go through this, but when you get the slide deck from me later on, there is a link for the concept progressions. This document shows not only the progression of the learner outcomes, but some of the main concepts that are found in that grade. So I guess we could call them some of the anchoring concepts, like I meant concepts that I identified earlier. So we've got anchoring concepts for each grade and each organizing idea on that document. Another interesting thing about concepts, they can relate to each other. They're not like transferable. We can connect them to each other in different ways to get different meanings. What we have here is a concept map of the grade 2 organizing idea of energy. It looks really complicated, but when you start reading it and following the lines, it does start making sense. For example, light and sound have certain sources. You can see that on each side. And if you follow the arrows along, so you can read the story of how this organizing idea actually unfolds and the meaning it has. So in this organizing idea, we're going to find that light and sound travel, or they have movement through different pathways. And in the case of light, light travels in a straight line until it hits an object. And when that happens, if the object is transparent, it could split into colors, which is a dispersion, or continue in a straight line, or can bend or refract. Some transparent objects include water and prisms and glass. Other objects that aren't transparent can be natural objects. They could be mirrors. In those cases, quite often, light will just bounce or reflect off them. And we could follow that for sound as well. Sound has certain pathways, has a movement in the pathway of travel, but it travels in all directions, and which can bounce off of things. And we also know they can travel through materials such as water, air, and salt materials, and so on. So that's how you can read that concept map when you pull it up, if that's useful to you. Let's look at the curriculum through, or this organizing idea, through the conceptual lens of understandings. Understandings are, and this is the definition of the guiding framework, understandings are how facts and knowledge fit together in a logical and meaningful order. How that is a pretty abstract statement. So what I'd like to do is just give you an example of what that means and how that looks like using this organizing idea. So we know that in the knowledge column, like we just looked at, that's where all the concepts are housed and their definitions. And in this particular case, we know that vibration, sound, object, and interaction are 4 of those concepts that show up in the knowledge part of this organizing idea. And they each have separate meanings. They each have a definition, and they each have their own meaning. So we can, what we often do is tell kids what they are. We work them together, and they know what the definitions are. They can find examples of them and so on. But that's not where it ends, because when you put those 4 things together, when you put concepts together in a statement of relationship, something happens. You get a different meaning. You get something wholly different than just the individual meanings of things. For example, if we read this first understanding, interactions between different objects can produce vibrations that make different sounds. Or we can reorganize the way those objects or those concepts are related and have something like this. Sound just produced by an interaction between objects that causes vibration. Same concept, 2 totally different understandings. And that's really what is meant by the definition that understanding is how facts, knowledge fit together in a logical and meaningful order. So on the knowledge side, they're just separated. They're not fit together. the understanding fits together the concepts or relates them together, and that's where we get the understanding. So not only do the individual concepts transfer, we could see examples of courage, like I said in those pictures, but the understanding also transfers. In this particular case, we could take that same understanding that vibrations can produce different sounds depending on the characteristics of materials. In context one, we could probably see that these two items can produce different sounds because they have different materials, or it could be different characteristics of their materials. Same with these two chimes. Their materials have different characteristics, and we could probably deduce that they would have different sounds as well. So that understanding can be applied to each of these contexts, which is an example how understandings are transferable. So we've been through a lot, and here's a quick summary. So bear with me as I read through quickly that we know that concepts have definitions and they have examples. We know that concepts are transferable and they're deepened through the grades, as we've seen when we looked at the progression of the organizing ideas, such as energy. Concepts can provide a focus, and we call that a conceptual lens. And they can build relationships with each other. We can arrange them any way. We've seen a concept map, and that's really how understandings are created as well. Concepts and relation create broader understandings, and they too can be transferred. So we've taken a look at two-thirds of the cusps, the knowledge and understandings, and now let's look at through the lens of skills and procedures. The skills and procedure statements, if you look closely, you will find that the do verbs of the skills or procedure itself comes at the front of those statements. In this particular case, we identify sources of light, we relate vibration to the production of sound, and we describe the characteristics. You'll notice that I have this highlighted here, and I'll show you why in the next slide. So the first thing we want to do is say, what is that verb? Where is it? What does it want me to do? What is that statement asking kids to do? When you've isolated, then you have to ask yourself, what is the statement really asking? Excuse me. When it comes to this bottom one, you'll see that it was really written in this way. It said, it should be one statement saying, listen to sound and describe their characteristics. In other words, it was all one statement. Really, the key here is that characteristics of sound is described. We have to listen to sound or describe it. I don't think the emphasis is on listening here too much as it is describe. So this is what we really want us to do here. The word identify shows up many times in the primary curriculum in science, and it means different things depending on how it's used. So you have to read that one carefully. In this particular case, identify sources of light and sound can mean a couple things. We know that if you go through some examples with the students, and you can ask them to recall that. So what were some of the sources of light and sound we talked about? Or you can go out in the environment and ask students to demonstrate their understanding of sources of light and sound by recognizing examples, which is a different thing when we're talking about identifying something. So we have to be careful, and you have to keep it in mind what it is really asking, because when you assess later on, you want to make sure that assessment piece matches with what the skill you're looking at here. So those are some of the things that happen in this organizing idea with the skills. But when we do take a look at all of them, you'll find that there are some that probably make up the bulk of the skills and procedure statement. There are some that become more important than others. And so what you'll want to do is tip 3 is really identify what are the key ones in the organizing idea, what are the key skills in the course, and maybe what are some of the competencies that might come in handy, because those are the ones that you'll really want to spend time on. As we'll see later, there's a process we can do to really clarify very clearly what the skill is, and spend some time up front trying to teach that skill itself separate from the content, so that the kids become competent in that skill and then can apply that skill to the content. And that way, when they do that, they're not going to be competing between trying to figure out how to do the skill plus understand the content. The skill will be already fairly competent in the hands of the kids, and then they can apply that and use the content without much interference from learning two things at the same time. So in order to do that, we have to take a look at all the skills and processes in an organizing idea. And here they are here. And you'll find that there's some things that, although they may be worded differently, kind of mean the same thing. In this particular case, we're looking at experimenting with something, testing something, performing simple experiments, building a simple device. It's really all about doing an investigation or an experiment of some sort. And if you were to do this without looking back at the computer science, or not the computer science, excuse me, but the scientific methods organizing idea, then you would be at a bit of a loss here. To do an experiment or to do an investigation, you have to take a look at that organizing idea to find out what is involved in investigation. And I have that listed here. You can find that link, or you can go to that in the curriculum guide. But to do an investigation, or an experiment, really, there are 6 steps. There are 7 steps. There are 6 steps that students go through in grade 2, and they're identified here. When it comes to observations and recording data, that is gone to more depth in the grade 1 curriculum. So you'll have to take a look at that organizing idea, scientific methods of grade 1, to get more information on what it means to record, how to record data, because it doesn't cover that anywhere else but in the grade 1 curriculum. Same with observations. So keep in mind that just like the concepts, sometimes the skills are also identified in an earlier grade and referred to in a later grade. So you may have to go back to find that out. Nonetheless, so that's where the investigations come in, excuse me, is where you can find that. And that's probably what you'll probably follow, is that 6-step process to really work with these, because they all, at the end of the day, can become experiments of some sort. So the key ones to focus on are investigate. I'm going to suggest that if you have a chance to do some comparing and contrasting, because it makes sense with when you're talking about different sounds and light and the different pathways and different materials and different characteristics and the results and the impact of different characteristics. Comparing and contrast would be a useful one to do. It does show up. I'm just maybe going to go back up a step here and show you this. These are all the verbs taken off from all the skills and procedure statement for each grade. So in kindergarten, for example, let's go to grade 2. Of the entire science curriculum, 11 skills and procedure statement begin with identify. And like I said, identify does mean different things when you look at it carefully. There's lots of discussion happening in grade 2 as well. Some description, there's investigate and then experiment, which kind of are similar things. And you can see here which ones are the biggies. So compare and contrast does show up quite a bit in other organizing ideas. But once again, if we're talking about transfer, if we know that compare and contrast is an important skill, it makes sense to use it as often as possible so kids become used to it and can transfer, compare and contrast, and use it independently and are competent in it at all times. So if it's an important skill, it does, compare and contrast shows up an important skill through grades 4 to 6 as well. So just because it's not in the organizing idea, I guess is what I'm saying, it's still a skill we would probably want to, if we find opportunities, and there are opportunities, especially in this organizing idea, where you can compare sounds and compare pathways, that you probably want to try to do that as well. And you'll notice discussion was a big one, and as well, but it's not in here, but it is kind of hidden in when you look at one of the final steps of an experiment where kids discuss their findings and share their work. We could also talk about collaboration perhaps being an important one. When kids are experimenting, perhaps they're working together on an experiment and they're collaborating. So there's things that we know are important for kids, but they don't always show up in the learner outcomes or in the cusps. But when we know, when we stop back and think about the beginning of this, say, what kind of a future are kids going to be facing? What do they need? Here's opportunities for us to say, okay, well, collaboration is important. I can integrate collaboration into the experiment. I can integrate compare and contrast in the experiment. And if you're interested to find out, what does it mean to collaborate at grade 1, the competencies in the New Learn Alberta site has them listed here, and they're broken down into the different divisions. So here's kindergarten competencies, Division 1, Division 2. And we know there's several of them. There's critical thinking. So critical thinking for kindergarten, here are some things to look for to get students to try to do at kindergarten for critical thinking. Here's what critical thinking means in grade 1. It actually means this plus the kindergarten stuff. So if we go to collaboration, we'll find that there are some things that students can do or should be expected to be able to do in grade 1, which would include all the kindergarten plus grade Division 1 things. If kids are discussing, you could probably pull some things out here. What are some benchmark things? What are some things about communication and discussion that students should be able to do at this grade? And so we can make up checklists and we can teach to those, say, okay, I'm going to be watching your discussion today. Here's some things that we need to remember, and put an emphasis on those kinds of things. So we have opportunities to teach those key skills and procedures along the way. So again, just as a review of where we're at now, we've taken a look at knowledge and understanding and skills, and they're all transferable. And the big question becomes now, well, how do we do that? How do we move to transfer? How do we get kids to be independent with their knowing and independent with their thinking? To find that answer, we look to Hattie, Fisher, and Fry and their stages of learning, of surface, deep, and transfer learning. They're basically 3 stages, and sometimes we move too quickly through them to try to get to the transfer, and students may not be ready. So to review them, we want to make sure they have a good surface level understanding. And surface doesn't mean shallow. Surface means a strong foundational learning. So when it comes to concepts, for example, don't confuse shallow with just me knowing the definition of a concept. Surface knowledge of a concept means that they not only can define a concept, they can provide examples of it, they can provide non-examples of it, they can see it in different contexts. Just as I said, for example, if I ask a student, do you understand the concept of courage? What is it? They can define it, and I can say, is this picture an example of courage? And if they can explain why, you know that they have a deeper understanding of that concept. When it comes to surface, deep, and transfer, it really is boiling down to the understandings, and I'll show you in a second here, because you can have a surface level just of the concept, which is the definition, but once you start identifying the concept into different concepts, they're getting a deep understanding of that specific concept, and they could transfer that understanding to different contexts. So they may be able to find courage in a novel, they may find courage in a news story, and so on. That's transferring that singular concept. What we're looking at here at stages of learning is not only transferring concepts to deeper, transferring single concepts, but when we get to that deep point, that's when we start looking at understandings. And the same goes with skills. We know that skills can be defined, and kids can list off, here's what we do when we do an experiment. But then the actual doing it and doing it independently and really and knowing what to do next without being told, that's what we want to try to move. So when people do investigations, students already know what to expect and know how to perform that, or comparing, contrasting, or knowing when to analyze something, or knowing when to evaluate something, and so on. So there's what we're trying to get at with those. So that's what happens to the surf. The deep, then, as you can see, I'm going to go to the next slide. You'll see the little concepts here that are boxes here. We've got them linked together. Well, that's just like the understandings, right? We've got 3 concepts in an understanding here, and we studied that in a certain context, and we tried again in a new context. Maybe using course material for this, or maybe we're still using new material and saving the transfer piece, the course material for the transfer piece. And you'll see that the background is even more different, because transfer is when the context really changes. Here's a new and unfamiliar situation. Try your understanding and your skill in this situation. And we know they're transferring when they can do that. When a totally novel or unfamiliar context and independence with the skills, we know they're in transfer mode. How do we get them there? Well, we use a variety of teaching approaches that can help them along the way. When it comes to surface and developing concepts. There's all kinds of things that can be done here. A lot of these things that are strategies you probably already do. One that's really helpful that I like, the card sorts are awesome, and where you sort pictures and cards and group them under and classify things to create the understanding of those concepts. That's a really good one. I like also the concept attainment strategy, and I provided many examples for you of concept attainment. I will show you them in a bit later. When it comes to the skills, probably the most important one for me that I found is this strategy called the direct teaching of skills strategy. It takes those big skills like I talked about, such as investigating or comparing, contrasting, or we could take a look at summarizing and evaluating, and use this approach with it. So I'm going to use investigating as that example, because the strategy itself is written on the left here. There are basically six steps at the surface level to introduce it and teach that skill at the surface level. And then once you get that, then you can take a look at how to deepen that skill and what might have to happen to get to transfer mode with that skill. But when we take a look at investigating it, this is the grade 2. I actually have 6 steps here. I don't know what happened. I think I separated a step out into 2. But we're looking at the first thing we want to do when you're planning for it is make sure you've got a clear definition of what the skill is. This is taken right out of the grade 2 scientific methods curriculum. So it's the process of making an investigation by using a set of procedures. We can define the concept, we can define it as well. An investigation is something. It's just something people do to find answers to questions. So it is a thing. Here, this is one of the important parts to any skills teaching, is to develop and list the steps that are involved. In this particular case, the steps are provided in the scientific methods. They're identified here. Once you know the steps, before you give it to the kids and say, okay, here are the steps of investigation, we're going to do one, make sure they understand the concepts in it. So this is the pre-work you do as well. Do kids, with pre-testing, do your kids know what questions are? Do they know what predictions are? Do they know what an investigation is before we even start one? Do they know what an observation is? Do they know what a record of observation is? Do they know what a conclusion is? And if they don't know those things, then that's still at the surface. We're still working the surface level here. You still then want to go back as you try to teach them the skill, but related with that are some concepts. So an example of how you may want to, just before you even get right into teaching this skill of investigating as well, let's take a look at what a conclusion is or what a prediction is. And so these things go through the concept attainment model of giving examples, not examples, having kids come up with what do all the yes examples have in common, to come up with a definition of what a prediction is, and then practicing making their own predictions here. So this is a quick look here. We have here 2 statements. One's a yes, which is an example of a prediction, and one's a no, it's not a prediction. And then they're shared with the kids. So for example, the surfer is going to fall. It's a prediction. The surfer is going on riding a big wave. That's not a prediction. And then you go through several instances of examples and non-examples to help kids develop those concepts. So now that's not the end of it, because then you have to keep on, that's just that surface level. Then you have to keep on providing instances for kids to make predictions. That may be during literature. It could be, stopping games, say, let's make a prediction here. We see this, what do you think is going to happen here? There are many ways we can throw predictions and have kids make predictions. They become familiar with it, and they can understand prediction in a whole bunch of contexts, so they've got it and they're ready to move forward. Not only are there concepts in this list of things, but there are also other sub-skills. For example, asking questions is important. Just making the prediction. What's involved in making the predictions is accessing your past knowledge and looking at the current situation and applying that to the situation to make a good guess, right? And then you go on and start practicing those. Do kids know how to plan? Do they know how to observe and make record and record data and so on? Can they make conclusions? Can they analyze the data? What are they good at with their discussions? They need work at their discussion skills. What does it involve? And how many different ways can you plan discussion? Not only just with the class discussion by raising hands, but there's all kinds of different things you can do with 4 corners or jigsaw, and different ways to organize discussions so that kids can practice those skills. And once you have all that set and they have all the concepts and they're pretty good at the subset of skills, then you share the steps with them. Okay, we're going to do an investigation. Here's an example. For example, which boat can hold the most marbles? And you go through all the steps with it and you demonstrate it, and then you continually give them some practice with guidance and more guided practice until they kind of finally get it. And that's the nature of teaching directly. I'm taking a bit too long. I'm sorry. So at the surface level, there's lots there are a lot of things you can do there. At the deep level, remember, the intent is to really for this part is to take those understandings and help kids form the connections between the concepts, and then take that understanding and see if they can see that understanding in different contexts. And some ways we can do that is by having kids make concept maps, for example. That's really good at showing them demonstrating their understanding. I'll give you an example of that in a second. And a key here is asking conceptual questions. And if the big skill here is experimenting, we know that experiments begin with a problem. And these conceptual questions are really good for the problem of an experiment. So your concepts would go on these blanks here. For example, does something cause something? That may be the problem. Would say show how, but after the experiment, when you have a different context, does interaction between objects cause vibrations? Really? Show how, because that's the understanding, and they can demonstrate that. But like I said, these conceptual questions can be the problem for the experiments. So if we were to take a look at this understanding that vibrations can produce different sounds depending on the characteristics of materials, the suggestion here is to do an experiment with sound using various materials and substances. So the problem then can be a conceptual question, right? And the conceptual question is basically going to be the understanding in question form. Can different characteristics of materials affect the production of sound vibrations? And get kids to make their predictions. And of course, why are you making that prediction? They're going to have background knowledge, prior knowledge. As if you follow Chris's videos, he's just got them practicing and doing things with all kinds of sounds. So by the time you do the experiment with them, they'll have lots of experience with lots of sounds. And then, of course, the conclusion, as we know, an experiment ends up with a conclusion. That would be the conclusion is going to likely be the understanding. Another way kids can demonstrate their understanding and to make sure if you want to test them out to see if they know their stuff, is to have them make concept maps out of the individual concepts. Now, grade 2, depending how many concept maps you've done, this may be too many things to put together in it, but what you do is you give a little piece of paper and have kids organize them in a concept map and say, well, and have them rationalize to you why they organize it in that way. And if they can't rationalize why they have texture, type, and shape sizes together here with characteristics, then you know they don't really still won't have that understanding, and you have to go back and maybe do some reteaching. For your first concepts maps, maybe you would just want to use a couple things such as material, characteristics, texture, and type, and just use those four and see if they can put those together. And as they get used to it, they'll get the hang of attaching more and more concepts together. So that's at the deep stage. And the transfer stage, this is where they are already independent with their concepts. They know them, they got the understandings. They're at the deep level with that. And now we can apply those understandings and skills, and we can set them off on some case study or maybe some big project that they can do. We know they have all the skills and everything already necessary for either the performance task or the project-based learning, whatever you're doing at transfer, to put it all together and have kids work at some project to tie up their organizing idea study. Of course, if there's stages of learning, there's going to be stages of assessment. So at the beginning here, there's concepts and skills. You can do some pre-assessing as you would ordinarily to see where they're at, what are they misconceptions, what do they know, what they don't know. And based on that, you can do some instructional activities, and then some other formative assessments to see whether they're ready to go to deep, to put those concepts together and understanding. And you're going to be practicing those at different contexts again. And then through formative assessments, you can find out where they're ready for that summative assessment or that transfer activity at the end. And during Chris's presentation, she's got lots and lots of videos and things they can all be used for those transfer activities. Even though there'll be, as she'll mention, there's videos that maybe are a bit repetitive. Those would be good because they're a different type of video using different contexts. You can ask kids in those videos, pause and say, okay, what did we just see here? Did anyone see anything about pitch or volume here? Or what kind of objects were interacting to create the vibration and so on? And asking those questions in those different contexts is in getting kids in that transfer mode. So Chris has lots of activities that will help you with that. If you're not too sure if you're assessing properly to see if my kids are ready to go from surface to deep, here are some questions you can ask yourself about the assessment. For example, can students state the definition or the meaning in their own words, especially if it's memorized, that you can ask them, well, what does that really mean? Can you say that in your own words? Can students distinguish between examples and non-examples or create their own examples? These two things are really good for deciding whether kids are moving on. At deep, there are some questions you can ask yourself as well. And at transfer, there's some questions you can ask yourself to see if that assessment is doing what it should for that stage of learning. And with that, then Chris will has her presentation coming up next. So please do stick around for that. She's got a wonderful, great ideas, and we hope that this last session for you has been valuable. And just as a reminder that we will be starting up some implementation sessions as well. There are people and teachers out there who have not done the piloting. We'll be beginning implementation, excuse me. So we will be providing some sessions, and feel free to join us when we advertise them, and perhaps we'll see you again. So thanks everyone for joining us. We hope that you've again had a good experience and you move forward in a positive direction with some efficacy and some confidence as we implement this new curriculum in the following year. Thanks everyone. Have a good day.